I got my BS degree in Taiwan, major in structural engineering, and then I got my master degree from West Virginia University, major in the foundation engineering, and PhD from University of Pittsburgh, major in structural engineering. And my dissertation for my PhD degree is in the shear diaphragm behavior using the middle panels. Okay, let me compare the other system. Try to put the new roof on top of the existing roof. A typical one is using a 3.5-inch G shape. Now, when this G shape also notch require, similar to the TopHat notch require around the outer rib on the panel, outer roof panel, and screw in here. So similarly, screw in here. However, because this G shape structurally is not stable, not symmetrical with the shear transfer into the top flange. Here you have two flanges, symmetrical profile. So when the shear load in here transfer into here for the bending stress, the profile is stabilized. It's no rotation at all. When you have this only on one side, this will rotate, depends on which direction of the load. When you have the positive direction of the load due to the, say, snow load, then this will rotate toward the left-hand side. When you have the uplifting load due to the wind, then this will rotate toward the other side. So all these strengths will be significantly worse. It may be because of the rotational problem causing the instability of the system. Maybe the new roof system put on is weaker than the existing one. Another possibility of installing a new roof system on top of the existing roof system is using a small head section on top of the roof panels, and then screw from here directly through the existing roof panel onto the existing purlin. What will this do? Because of the cantilever distance for the roof from the roof head into the existing purlin, this distance destroy the composite action, because simply shear cannot transfer through this point, from this point to that point. You can see the transfer distance is almost zero when you tighten up the screw on this one. And here you shear go this way, the other force go that way. It simply will tilt the fastener, and no composite action you can get. And then on top, that means when the wind load or the structural load due to the snow load is concerned, when this try to take up the load, then causing this screw to rotate, and the degree of rotation could cause the collapse of the existing roof. And maybe somebody say, why don't you just use a short screw into the existing roof rib? What way this do is existing roof is normally very thin gauge, and the pull out load capacity is so minimal. So it's simply structurally this is even worse than the G-shape design as I talked about before. So this is certainly structurally this is no good at all.